So this is 2.1 constant of proportionality as rate of change, and we are on page M2-25. So here's the problem. On Monday, Jack and Jill walked from their home up a hill to get to the bus stop. They walked 4 yards every 3 seconds. Write an equation to represent the distance, d, Jack and Jill walked over time. So remember, this is that, let me get my notebook out and turn to the page that we need. So remember, this is how we set it up. It's distance over time. So we're going to set up our unit rate so that we can get our equation, because remember, the constant of proportionality is the same as the rate of change. So we're going to do y equals the rate, or the number with x, is our rate. So if we look, they're walking 4 yards every or over 3 seconds. So it's distance over time. So you're going to say, so our equation would be y equals, remember, kx, where the k is the rate. So instead of writing y equals kx, we're going to say y equals 4/3 x. And that would be our equation. Oops, except for, I did not pay attention. It says d and t, distance and time. So I'm going to actually write that as d equals 4/3 t, because you're going to multiply the rate times your time. So if they went for 3 seconds, 4/3 times 3, then it would give you your distance. So it's actually this one. The only thing that's different is, instead of y being the distance or the yards, the d is the distance. Okay, we're not going to do number 2. We're not talking much about proportional anymore. Okay, we are going to do number 3 though. You will notice that I marked out this row and this row. Until we get better at filling in tables, I'm going to leave it like this. So if my time spent walking, if I've gone 0 yards, how many seconds have I gone? Well, 0 seconds, because they are where they started. Now we're going to follow this rate up here, the 4/3. We're going to follow that rate. So if I want to go 4 yards in 3 seconds, so I went from 0 to 3, and then I'm going to go from 0 to 4. So then after 3 seconds, they're at 4 yards. We're going to continue that pattern. So then the next thing that they're going to do is they're going to walk 3 more seconds. 3 plus 3 is 6. 4 plus 4 is 8. Okay, do it again. 8 plus 4, which is our rate, 8 plus 4, so 8, 9, 10, 11, 12. And then this went up 3 seconds. Okay, now the next thing that we're going to do is graph the points. So we filled in our table, now we're going to graph our points. So if Jack and Jill went 0 seconds in 0 feet, I'm going to go time spent is 0, distance would be also 0. So I'm going to put a point right there. Then I'm going to go to 3 seconds. So I'm going to go over to 3, and then I'm going to go up to the 4, so distance of 4. So there's that. I'm going to erase those little dashes that I drew just so you don't get confused with all the lines everywhere. Then I'm going to go to 6 seconds, and I'm going to go up to 8. So right there, I just did invisible like dashes like I did, and then went over to 8, or went to 8 and then went over. Okay, then I'm going to go to 9, 12. So I'm going to go 9, and I'm going to go invisibly up, so it's somewhere along this line here, and then I'm going to go 12, and it's where those two cross. But again, you don't want those lines everywhere, so you might want to erase those. Okay, we are going to connect those, so if you have another piece of paper, the edge of a notebook, I just happen to have a note card right next to me, so I'm going to use that note card, and I'm going to draw that line. Okay, so that is what the graph would look like. Remember, time is along the x-axis, distance is along the y-axis. Okay, let's go over here. So this says, what is the unit rate? So remember, if you look at your notebook, the unit rate is always per 1 unit. So we found our rate of change was 4 yards in 3 seconds. But I don't want to know how much they're moving per 3 seconds. I want to know how much they're moving per 1 second. So to find that, you're going to divide 4 by 3. So you'll want your phone or your computer calculator or whatever you're going to use, but you're going to type in 4 divided by 3, and you get 1.33333333. Okay, which would just be, I'm going to do 2 decimals, so I'm going to do 1.33. Okay, so then that would be our unit rate. Okay, so first thing I want to do is I want to mark a few things on this graph. So we said that it was going up 4 for every 3. I want to show that on this graph to show that it's the same thing whether you're looking at the table or you're looking at the graph. So from this point to this point, we're going to see how much it goes up. And so you're going to see me mark that little line. And then we're going to see how much it goes over. And I'm going to show you that it's the same thing. So it started at 0, and then it makes it to 4. Well, how much does it change from 0 to 4? Well, that's an increase of 4 yards. Then, if we look this way, it started at 0, and it ends up at 3. So from 0 to 3, that's a change of 3. And then let's look again. So from 4 to 8, from 4 to 8, that's 4, which we found right there. And then it's going from 3 to 6. Well, from 3 to 6 is 3, just like we found here. And then we're going to do the same thing on this one. From 8 to 12, that goes up 4. From 6 to 9, that changes by 3. So it's kind of like little stair steps, I guess you could say. It's going up 4 over 3, up 4 over 3, up 4 over 3. Now, this next question, it says, explain why Tanner's reasoning is incorrect. So here's Tanner's statement, and then explain why the graph goes up as they move from left to right. So Tanner said, this graph goes up from left to right because Jack and Jill were walking up a hill. Now, does that actually mean, or does the graph show that they're going up a hill? So it did say that they went up a hill, but if we look at it, it says Tanner's incorrect. the graph does not just go up because they're going from left to right. Well, let's think if we were talking about them going down a hill. So let's say they're on their way home from the bus stop. So let's draw a fake little graph right here, and we're going to say this is time and distance. So if we're going to say how far are they from home distance, or from the stop distance from bus stop. So if they walked uphill on the way there and then they walk, that means they would be walking downhill on the way back. So they're going to start at the bus stop, so 0 time is 0 distance. Then let's say that they walked for 2 seconds and they got to the 5. So they walked for 2 seconds and they got 5 yards away, and then they're going to continue walking, and that was 10 seconds. So notice this graph is still going up because as they get further away, their distance is increasing. So he's not correct, because as you walk away from something, your distance is getting further and further. It's not because you're walking uphill or you're walking downhill. It's just that as you get further and further away, it's taking more time and you're getting larger distance between you and the bus stop. Okay, the last thing that we're going to talk about is what would the rate of change, we're going to skip all of those ones, but we're just going to do number 8. How would the rate of change in the graph of the relationship change if Jack and Jill walked faster? How would they change if walked slower? So if we look at this graph, and I want to say, let's say they're going 6 feet instead of 4 feet. So, oops, I moved my paper, and so now it looks like it's all off. Okay, there we go. So now let's say they walked 6 feet. So that means in this same time, they're going to walk to the 6. So it's going to be there. So 3 seconds, they walk to 6. 6 seconds, we're going to go up 6 again. So 1, 2, 3, 4, 5, 6 in that same time frame. And then we're going to go up 1, 2, 3, 4, 5, 6. Ah, it would be up there. And it would be somewhere up there. I'm going to use my note card again. So, it'd actually be even higher up than I drew it. So look at what happened when they went in a faster rate. So when they went faster, they're covering more distance in the same amount of time. So it's going to go a lot quicker. Do you see how it's going up higher? So this one's here, and then now it's up here. So they went more distance in the same amount of time. So that's what would happen. Now if they were going slower, it would be this direction. Because they would be going, let's say, up 1 foot every 3 seconds. So if they were going 1 yard every 3 seconds, they were walking really, really slow. They didn't want to get home because they thought they were going to get in trouble. Then it would be like this. Okay, we will cover that more later on, but I just wanted to answer that question now. Okay,